Today is Lesson 32, Writing Proportions. Today's objective, we're going to write an equivalent ratio to create a proportion. From our lesson yesterday, we talked about proportions that are ratios equivalent to each other, and we can find out that they're equivalent to each other by multiplying or using equivalent denominators. So when we're talking about proportional reasoning, it is the ability to make and use multiplication comparisons among quantities. It's a statement of equality between two ratios. So today we're looking for another set of proportions. Again, two ratios that are equivalent to each other. Equivalent, that means that they are equal to each other some way. We need to identify what are the parts that we are comparing with each other. Okay, so today's first example is 7th grade boys to 8th grade boys. We're comparing the 7th grade to the 8th grade. And if we look at our chart, we have 7th grade, both boys and girls, and 8th grade, both boys and girls. So we said we're looking for the 7th grade boys, which is this number, and we're looking for the 8th grade boys, which is this number. And we need to create a proportion. So first we need to identify the parts, 7th and 8th grade, by writing down what our units are that we're using. When we get into more complicated ratios, the units will help us know where exactly to place our values. So for the first one, we're given the value that there are 26 boys in 7th grade and there are 30 boys in 8th grade. We want to find an equivalent ratio to make a proportion out of this. So in this case, we're going to simplify this ratio. To simplify this ratio, we need to divide by a number to get a new ratio. So in this case, the number that's best to divide by is the number 2. Very good. So 26 divided by 2 is 13. And 30 divided by 2 is 15. So our proportion then is 13 to 15 is equivalent to 26 over 30. Using the same chart, we can create a different proportion. In this case, we are looking to identify 7th grade students, this time all of the students in 7th grade, to all of the students in 8th grade. Okay, so again, write down what your units are. So we're doing 7th, I'm going to put 7th students to 8th grade students. And our first ratio, first we have to identify how many we have all together, because this includes both the boys and the girls. So if we add 26 plus the 34 girls, we're going to get a total of 60 7th grade boys and girls. If we add the 30 boys in 8th grade to the 22 girls in 8th grade, we get a total of 52. So when we place those values in our proportion, or actually in our ratio, we have 60 7th grade students to our 52 8th grade students. Now right now it's just a ratio, but to create a proportion, we need to make an equivalent ratio. Again, I would go ahead and simplify this to try to find an equivalent ratio. Now you can multiply to make it larger using multiples, but simplifying and dividing is often easier to do. So in this case, I could divide by 2, but the best number to divide by this time is 4. So we're going to actually divide this whole ratio by 4. And 60 divided by 4 makes 15. I always think of a clock when I have numbers that are 15, 45, 30, 60. It makes me think of increments of 15 on a clock. And 52 divided by 4, usually not as easy to do in our head, so you are able to use a calculator for this unit, but in this case, it would be 13. So our equivalent ratios, which make a proportion, would be 15 to 13, 15 7th grade students to 13 8th grade students, equivalent to 60 7th grade students and 52 8th grade students. Sometimes our situations cannot be simplified. So in this case, we have 7 cars to 12 footballs. What are the parts that we're comparing? We're comparing cars to footballs. Okay, so when we go to write our ratio, first we're going to identify our parts, cars to footballs, and it always goes in the order that it's mentioned, unless the problem asks it in a different sort of way. Maybe sometimes they're in reverse, so we have to always read carefully. In this case, how many cars do we have? We have 7 cars. How many footballs? We have 12 footballs. There is nothing we can divide 7 or 12 by, so therefore we're going to multiply. Actually, if I use the multiplication symbol instead, that's much better to figure out how to find an equivalent ratio. So I'm going to multiply by 2 in this case. So 7 times 2 is 14, and 12 times 2 is 24. Very good. So our equivalent ratios, which again make a proportion, are 7 to 12 is equivalent to 14 to 24, and therefore that is our proportion. In our last example for today, we have 4 soccer balls to 11 players. So the 2 parts that we're comparing are the soccer balls to the players. All right, so I'm going to abbreviate soccer balls over our players. And we have 4 soccer balls for every 11 players. This is just a ratio, but I need to make a proportion. I cannot simplify this by dividing, so I'm going to multiply. I'm going to multiply. You can multiply by any number, but usually 2 is sufficient enough. It's a very easy one to do. So 4 times 2 is 8, and 11 times 2 is 22. So therefore, our proportion is 4 to 12. I'm sorry, 11 is equivalent to 8 out of 22. And that's today's proportion. Now it's your turn. On the You Try page in your notebook, I would like for you to write down 2 equivalent relationships or ratios that create a proportion for every given situation. Copy these 2 word problems down into your notebook and write your 2 ratios showing how you figured out that your ratios are equivalent to each other.